Welcome to this Small Cell Forum webinar on the topic of FAPI. I'm Simon Fletcher, Chief Strategy Officer of the Forum, and we've got a expert cast with us today to talk through the latest release of FAPI, which is now on version 10 and has been going for a number of years and goes from strength to strength in terms of the features. I won't do the introductions now on the presenters. I can introduce themselves as they present their slides in the deck. Next slide, please. So just a quick summary of FAPI, 5G FAPI. FAPI itself has been going as a concept for quite a number of years. Well before 5G in the 4G era, but we're talking here about 5G FAPI and the ecosystem and use cases that are associated with that. So really, a lot of the expertise within the forum is in the hardware and software around the MAC and PHY and the product and component development ecosystem that focus on the small cell product lines. And that's where the FAPI specification operates. So really, it provides us with a functional view that is intended to be quite factual in terms of what is required in the interface in the layer 1, layer 2 area. It's very nicely coupled into 3GPP and ORAN. We have a degree of flexibility as a forum in terms of how we choose to align with those organizations, which you'll hear about as we go through the presentations today. Now, the goal really for the forum is to focus on encouraging competition and innovation and encouraging a scenario where we are having a successful delivery of products and components into the market to enable commoditization of particular interfaces and cost-optimal solutions. There have been a number of contributors to the specifications over the years. A few of the companies listed here that are notable in terms of this particular release and a few preceding ones. Yeah, it's been very much an effort of a number of companies over many years to persist and maintain the FAPI specification. And with that, I'd like to hand over to the rapporteur, or leader of the FAPI group at the moment, Andre from Qualcomm, who will take us into the details of release 10.
So thank you. This is Andre. As Simon mentioned, and thank you for that introduction. I am the delegate from Qualcomm, also serving as a FAPI rapporteur for the FAPI 5 specification. And here we see the list of interfaces that are currently subject to FAPI, where on the top you see the layer 2, layer 3 application software, and on the bottom you see the layer 1 support hardware, platform hardware. The interfaces between the two are represented by these P-numbered interfaces, P5 and P7 being the configuration and slot level interfaces that we're all familiar with. P4 supporting small cell deployments via access to the network monitor module. P19 was the interface introduced in the transition to 5G for analog beamforming, but also supporting hybrid beamforming. And more recently, in order to support integration with the ORAN front haul split 7.2x, the P9 interface permits configuration and capability inquiry with respect to the ORAN interface that terminates in the layer 1 platform hardware. This slide shows the evolution of the FAPI specification. So we started with the FAPI small cell specification in 2020, about 5 years ago, and we've had roughly 2 releases per year. And originally we covered release 15, and then in 2021 we switched off to focus also on the macro and the massive MIMO use cases. So we added those use cases as well as a dynamic shared spectrum to the specification and tightened up the specification. We also started covering release 16. That release 16 coverage has continued throughout many years. So in 2022, we added a couple of more release 15 features. We also integrated better with ORAN front haul. Background compatibility as a release as a key aspect was introduced in 2023, and it's validated back to FAPI P6. That's when we also introduced the P9 specification for the purposes of interfacing with ORAN. In 2024, we continued the release 16 March. Introduced also concepts of virtual RAN and centralized RAN. And this year we started addressing release 17 with red cap and coverage extension. We also continued addressing ORAN, and the key part of maintaining reliable interfaces. Maintenance occupies a significant portion of the FAPI work item tasks, and that has been going all throughout, ensuring that the specifications are of good quality. This is a architecture diagram that we are probably familiar with. The FAPI specification 222 is key to all of this, running from distributed small cells in the integrated box. In split 2, the 3GPP DU also accommodates the FAPI interface between the OEM software and the platform hardware. In split 7.2, the FAPI interface serves inside the DU as an interface between a platform software and a layer 1 ASIC, or could also be a layer 1 accelerator. And for our native split 6, FAPI is present between the DU and RU components and transported over the NFAPI. And the various support specifications are listed on the right. They are key to ensuring that these architectures are complete from a point of view of interfacing specification, and the standards are available to be followed to simplify the implementation. So with this, I hand over to Vikas from Geo, who will cover industry alignment.
Thank you, Simon and Andre. This is Vikas from Reliance Geo. I'm working as a VP with Reliance Geo, and also supporting the small cell forum in reviewing and also providing the input to various papers that was published from a small cell forum, and also the specification for the FAPI and the NFAPI. I also do contribute to ORAN Alliance. So happy to see both of the organizations working together. Next slide, please. As Andre mentioned, that in a small cell forum, we don't work in the isolation. We started the 3GPP base FAPI specification, and later on included the features not only from the release 15, but going on for the release 16 and 17. And also the FAPI specification has been enhanced not just for the small cell network, but also the macro network related features, which are essential for release 16 and 17, has been incorporated into the FAPI specifications. One of the features that I like to highlight is two-step batch procedure, which is very necessary for the IoT kind of the use cases where the quick access to the network is needed, is also being supported. Positioning related aspect has been added, and also the interference management related feature has been added into the different releases of the FAPI specification. We have a process in which we try to include the features from the specifications into the FAPI, and these are based on the input that we received from the industry. And if any one of you want to be part of features that you want to be part of the FAPI specification, please reach out to us. Not only the 3GPP, the FAPI specifications also support the ORAN specifications, mainly the working group 4, which is the front haul specification. So it supports all 3 control plane, user plane, synchronization plane in the FAPI specification. So you can have a FAPI specification between the MAC and PHY, and between the PHY upper and PHY lower, you can use the ORAN specifications, which Andre also mentioned. The newest features like uplink performance improvement and advanced sleep mode is also being incorporated into this version of the FAPI specifications. Hybrid beamforming is also one of the very essential features for the beamforming related activities, has been incorporated. And also the FAPI specifications support the split and the virtual function between the CU and the DU is disaggregation. So those kind of aspects are also being supported by the FAPI specification. So you see, we started with the base, but we incorporated many advanced features from 3GPP and the ORAN going forward in the different releases of the FAPI specification. And FAPI specification is is very stable at the moment in terms of release 15 and also the other feature which has been added on top of it. Go to next slide, please. Okay, within the forum itself, we have created a DAS tool, which stands for Disaggregated RAN Transport Analysis Tool, because we see that the transport is going to play a major role while deciding a deployment for a particular scenario. So the forum initiated this activity, and there are 2 versions of the DAS tool. One which is freely available, the link is provided here, along with the paper that how to use the tool. Although it's very simple way how to use the tool, but we provided a paper and along with some of the use cases. So, but what the DAS tool do is that it gives you the transport requirement if you choose one split versus another split in a particular deployment. So it analyzes the transport requirement right from backhaul to split 2 to split 6 to 7.2 to split 8. And it is being used already used by the different industries already. And there's an advanced version of the tool in which have multiple features, not just the basic feature which has been part of the free calculator, which is Excel-based tool, which is only available for the members of the small cell forum. So if you want to get an access of the full tool, please join us. Then we have another paper related to the darts and the disaggregation. SCF 260 has already been published. It shows that which are the major kind of the split which going to be prominent has been published a couple of years back, but it is relevant in today's scenarios as well, where we see the deployment based on the disaggregation at this point of time. There are two upcoming papers which I like to mention here. 261, which is disaggregation use case and choices. So it has the details about the various transport mechanism available, their advantage, disadvantage, limitations, where they will be used and things like that. And along with the two of the use cases, practical use cases, where the DAS tool can play a major role in deciding which split need to be chosen. And another one coming up is SCF 270 for the stadium deployment. So you see, this is not only for the small cell, but for a bigger deployment like the stadium, the tools can be used. Apart from that, I like to mention is that from the 3GPP and ORAN Alliance, we also do collaborate with the Open Air interface, and which has adopted the FAPI interface, and they keep on updating their software based on the FAPI releases. They support multiple features which are consistent with the FAPI signaling. The 3GPP base, two-step RAG, reduced capacity, massive MIMO, codebook SRS. This has been supported by small open air interface software. Open RAN based like Open Front Hall, M base, Category B, FR1 beamforming. And in terms of the architecture, it supports the NFAPI and also the FR2 beamforming. So from the small cell and the FAPI point of view, and specifically this version of the FAPI specification, it has various useful features from the other organization as well. We work in collaboration, and this we wanted to continue in future as well. Thank you. I hand over to Ganesh now for the further updates.
Thank you, Vikas. We'll talk about NFAPI, Ganesh Environment from Radisys and the NFAPI specification rapporteur. So we'll talk about NFAPI, how it is becoming the part of the versatile FAPI suite. And the FAPI suite has become more mature, elaborate, and very versatile, as both Andre and Vikas pointed out. And NFAPI, to demystify a little bit, if you can please go to the next slide, please. It's the network layer or wrapper on the FAPI messages or the FAPI protocol. And you see the visual representation here, where the aspect of NFAPI is brought out, how it is carrying the FAPI messages through a network layer or a wrapper between an SDU and an SRU. These are our terminology in SCF to denote a DU, which contains the layer 2 plus functionality, and RU contains the full 5-layer functionality and the RF aspects. And both the SDU and SRU can communicate with each other or this NFAPI interface, or we call it a NFAPI front hall, to kind of contrast this with the other front hall, which is the ORAN front hall, which is seen as a 7.2x split. This is an option 6 split. And this front hall is going to be less stringent in its requirement, and the messages and procedures have been defined in such a way that you can deploy with less stringent requirements on timing and throughput, jitter, such characteristics. So this NFAPI front hall is very essential to deploy multiple small cells with an option 6 split. And we also use the PNF and VNF terminology, which will be covered in the next slide. And the versatility of this specification, which when we talk about it, we cover all the messages that are embedded in the FAPI suite, basically P5, P7, P4, P19, all are covered in a network wrapper in FAPI protocol. If you can go to the next slide, please. Yeah, here we show how exactly this is translated and transmitted over the network interface. So the control messages are the signaling messages, typically the P5 kind of procedures, also the P19 analog control interface control messages as well, and the P4 NNM kind of messages. And we have one more slide coming up explaining this again. But these control messages are reliably transferred over an SCTP interface. SCTP is a reliable protocol, communication protocol. We use that transport to reliably transfer the messages between the SDU and SRU. We also see this PNF, VNF terminology being used extensively in the specification. The PNF refers to the SRU, the non-virtualized part of the radio, and the VNF can be virtualized, the layer 2 functionality or even layer 3 functionality, the DU and CU portions of the G-Node B can be virtualized, and we call them usually in our specification using the term VNF. So you will see a lot of PNF, VNF terminology being used in the FAPI specification. And the control messages which we talked about are reliably transferred over SCTP interface, and the user plane or the data plane messages have to be transferred very fast with low latency, and they are transferred over an UDP interface, UDP protocol transport. And here we take care of multiple things: slot level data transmission, and all the synchronization required between the nodes is covered extensively through a detailed synchronization procedure, and all the delay management based on the characteristics of the FAPI protocol. They are all already set at the initial time of configuration, and the nodes can talk to each other, transfer data. And the data here would be the P7 messages and the P19 S slot-based messages. And with this set of clear demarcation and the appropriate headers defined for this, we are able to really encapsulate and keep pace with all the underlying changes of FAPI protocol. As the FAPI protocol evolves for multiple features across 3GPP releases and other capabilities to extend for different types of deployment, FAPI is able to wrap around those messages, and that's the consistency or alignment that we maintain between the FAPI and FAPI specifications. If you can go to the next slide, please. So we talked about the config messages and the slot level messages, the diagram showing the different interfaces of the named P interfaces, which Andre mentioned. The control sound like interface, network monitoring interface, P4, P5 messages, cell config, P7 data messages, and the ONM interface, which is special P9, and the P19 analog beamforming control messages, all are nicely wrapped in FAPI. And that's the summary of how FAPI supports this. And as an evolution or roadmap of this specification, we've been making updates to keep pace with FAPI. And as FAPI evolves, we'll add more messages and make new releases of FAPI. And if there are specific features that need any significant update for the FAPI protocol, we will do that too. For example, the NTN feature, if it adds any significant capability that requires FAPI protocol to be upgraded or updated, we will do that. And another study item, which is mostly from a deployment considerations, where we add some recommendations in the specification, is on the non-ideal front haul to be used for FAPI. And in that case, we are drawing lessons and feedback from those who are deploying the FAPI interface, option 6 split. If there are specific characteristics that needs to be addressed as recommended settings and configuration from the deployment of different types of transport, we incorporate that in the recommended appendix section, and that's going to be helpful for you to deploy the FAPI interface. So that concludes the last slide I have, and over to Martin now for the next update. Thank you.
Thanks, Ganesh. So I'm Martin Laseko. I work for RAN Semi, based in the UK. So I'm going to talk about small cell support in FAPI, a number of activities that we participate in. So next slide, please. So first I'll talk about a couple of companion specifications to the main specification, which is the SCF 222. So we have, firstly, we've heard mentioned P19. P19 is the front-end configuration specification. It handles aspects of the physical radio, such as setting power, frequency. It also includes analog beamforming control, which might be appropriate in, for example, millimeter wave FR2 type products. The focus of P19 is small cell use cases and primarily the RF configuration. It's currently in maintenance. The last formal release of P19 was August 2023. Now, I mentioned analog beamforming control. There are other beamforming methods. There is a hybrid split 7.2 beamforming method. Decision was taken it would be more appropriate to incorporate that functionality in SCF 222, which is the main 5G FAPI specification, and that was released in July 2025. Moving on to network monitor mode. Thank you. Moving on to network monitor mode, we have the P4 interface. Network monitor mode is it's a multi radio access technology feature. It's highly appropriate for small cells and particularly applicable to shared access license type deployments. It covers network monitoring of RATs, including 2G, 3G, 4G, and 5G. It's a stable document. It's feature complete and is currently in maintenance. The last formal release of this document with a few minor fixes was made in February 2025. So next slide, please. Other activities in Small Cell Forum which are associated with the FAPI specifications are listed on the slide we see in front of us. So we have a number of small cell study papers. So starting back in 2022, we produced an NR-FR1 reference design paper. The objective of this paper was to provide an overview of the components and interfaces that may typically be seen in a 5G small cell radio. And it's a helpful document in providing the context for FAPI. So over on the right-hand side, we can see a diagram showing a typical small cell. Shown in this diagram, we've got what may be a collapsed G node B, in that we've got layer 2 and layer 1 functionality co-located. And then annotated on the diagram, we've got the applicability of the various FAPI interfaces, P5, P7, P4, and P19. In 2024, a new activity was started, SCF 253, which extended the FR1 reference design to considerations around millimeter wave FR2. So if we look at the diagram on the right-hand side, we can see that the RF front end has grown to incorporate beamforming. And fresh to 2025, we have an activity looking at non-terrestrial networks. So I have two outputs. One is Small Cell Forum SCF 263, which will be a complete paper detailing candidate architectures, and there'll be a summary paper, SCF 262. Now, I should draw viewers' attention to the subtitle. So the title of the paper is Small Cells and Non-Terrestrial Networks, Common Challenges and Common Solutions. And the reason for that subtitle is we see, or we believe there is a lot of commonality between small cells and non-terrestrial network solutions. And the commonality comes in the form of things like size, weight, power consumption, component choice, and architectures. So we think NCN is a good fit to be studied within Small Cell Forum. So this activity recently started. It's being led by Vicky Messer. It's in development now. We're aiming to have a publication later this year. The focus is on GNOB regenerative architectures. And out of this study, there will be allied work in FAPI. So expectation is that the NCN team will collaborate with the FAPI team in identifying both 3GPP and non-3GPP functionality that needs to be added to FAPI release 11 in order to support NCN applications. So with that, I'll hand over to Andre, who's going to talk about uplink performance improvement.
Hi, thank you. So I'll be presenting this this section normally from Anshuman Bozi from Marvell. The voice is, however, Andre. Anshuman could not be present for this particular recording, but this is a presentation of a particular feature that was recently introduced in split 7.2x in ORAN. World Group 4 and was also adopted by FAPI. What we see here is the impact of this feature in FAPI from an architecture perspective. Principally, as a short description, the feature aims to relieve front haul load and also improve channel estimation by moving the channel estimation to ORU, and this goal, the goal of this feature is essentially to allow channel estimation to be performed based on the PDSCH DMRS PUSCH DMRS pilots. By effectively doing that estimation, the resulting equalizer is able to avoid the channel staleness and is also able to account for intercell interference. So that means that from the point of view of FAPI, where originally the equalization and channel estimation features were both handling DU, which is essentially upstream of the front haul. Now the channel estimation, and depending on the ULPI feature, maybe also the equalization, are handled in the RU. So you can see on the bottom the cases for the ULPI where there are two of them, with the ULPI what's called the Class A DMRS PFA. Channel estimation happens in the RU and equalization in the DU, and with Class DMRS, sorry, the other way around. The Class A, the channel estimation and equalization, both of them happen in the RU. With Class B, the channel estimation happens in the RU and the equalization happens in the DU. So both of these mechanisms for uplink performance improvement are architecturally supported in FAPI, where appropriate capability supports and P7 fields. So starting FAPI v7, FAPI v10, ULPI is therefore also supported part of the FAPI features. So now I'll switch off to the next topic, which is ASIC support. So now I'm back presenting Qualcomm slides. So for so this is Andre, now as a Qualcomm delegate. So the main idea for FAPI as an ASIC interface is that an ASIC is designed to handle features that are specific to wireless communications, and such an ASIC is not a general processing engine. And since it's not a general processing engine, it has to be presented with data structures that account for the particular capability and accelerations that are enabled in FAPI in the layer 1 ASICs. So as an example, I list here 4 features. One of them is rate matching. That's a downlink feature where a PD-SCH transmission may overlap or be rate match around other signals such as SSB, broadcast, and CSIRS pilots, and other types of structures. So the FAPI specification lists the structures and links them together, so layer 1 doesn't have to use general processing, to do that linkage. Next is that native support for word alignment and padding is now baked into FAPI. So there is no need for FAPI to worry about the misalignment between parameters and word boundaries. So the padding and word alignment features enable that as an optimization. Another feature that is ASIC friendly is the way the data is and the structures are presented and ordered. So we already talked about rate match earlier. Another aspect is how MU-MIMO structures are presented rather than for instance, for downlink, the PD-SCH data structures, or for the PUSCH PDUs being presented individually. They are presented also linked together in allocations where all users share the same rectangular regions. Those are MU-MIMO groups. And by having these data presented together, the ASIC implementations is able to focus on the key aspect of wireless processing. And last, a feature that is introduced in FAPI v10, we take advantage of the fact that various CCH formats are intended by 3GPP to be code multiplexed on a per format basis and on a fully overlapped basis. So as a consequence, taking advantage of that design guidance into the GPP, now it's possible to optimize processing and avoid unnecessary error checks by introducing requirements for layer 2 to align with the GPP signaling assumptions and ensure the formats are coded together and are also are not either fully overlapping or not at all overlapping. That simplifies both internal processing as well as interfacing with the ORAN, CPIN, and UPlane. Last but not least, the FAPI interface is both flexible and extendable. It's flexible by introducing 3 transport options, one of them functional, another one simple, another one FAPI based. So the functional one allows vendors to agree that FAPI presents the interface as a bunch of parameters, but vendors are free to determine in which way those parameters are presented the interface. So if the functional transport is implemented, then it becomes a vendor decision. The simple approach is presents the parameters in the order in which they're listed without strict requirements for padding and alignment and transport. And last, the FAPI-based option, which is also presented for FAPI, which comes with strict requirements on word alignment and padding, together with adaptation to a transport layer, as well as associated delay management. And the last one enables OEMs to align at a bit level. The interface, as I mentioned in the introduction, is fully backward compatible, so releases beyond FAPI v6 essentially are compatible with earlier releases. And last, we focus on keeping the design simplistic, minimal, and aiming to capture the GPP and ORAN features as in the generality. And this way, by introducing a few features, we capture as many features downstream of the GPP and ORAN as possible. So now we'll switch off to the next section, which is still presented by me as Qualcomm delegate, Andrei Radulescu. Here I'll introduce MIMO evolution, CRAN, and VRAN. So for MIMO evolution, there are a bunch of MIMO architectures, starting from semi-static recording, making use of CSRS-based feedback or SRS-based feedback for both uplink and downlink, enabling multiple TRP architectures as well as analog and hybrid beamforming. So for the two types of architectures, semi-static and dynamic, you can see here as an example for the downlink case. On the top, the semi-static architecture separates out precoding and beamforming, where the beamforming essentially can think of it as realizing the virtualization of CSRS ports, and precoding realizing the mapping of downlink layers onto CSRS ports. And on the bottom, you can see the dynamic architecture, where layer 1 is responsible for dynamically generating beamforming weights based on SRS observations. And though in this case, the precoding and beamforming architectures are coalesced together into dynamic weights that for beams that are derived in layer 1 between layers and TX chains. Similar concepts apply to the uplink. Another aspect that was introduced in FAPI v10 is that as part of interfacing with ORAN, now we have essentially hybrid architectures, which are not necessarily compliant with the P19, which was intended for small cell deployments. ORAN realized a while back that the analog and digital parts of hybrid beams are updated at different sort of rates. So analog beamforming might be let's say, slower than digital beamforming, which might operate at the symbol or even at the frequency level. So by separating out the two messages, the types of beamforming, ORAN achieves savings in terms of both signaling as well as complexity. So we adopted the ORAN approach in SCF 222, where the digital beamforming is maintained as before. The analog beamforming portion of hybrid architectures, hybrid antenna architectures, or is treated as a separate type of signaling via time domain beam groups, where time domain beams are essentially what we call analog beams, and frequency domain beams are what we call digital beams. So now this type of signaling is supported in SCF 222 exclusively without relying on P19. This lists a summary of the MIMO type beamforming and precoding features that I just discussed. Also at the bottom, I add the MTRP case. So we had the MTRP case, which is focusing on the release 16 MTRP downlink enhancements that were introduced by TGPP for 2 TRPs. In FAPI v10, we generalized that to cover more than 2 TRPs and could also cover the uplink and downlink. Although because of the release 16 features, if one uses the release 16, approach for downing beamforming the Release 16 features used 2 TRPs at a time, but there could be 2 different TRPs for each UE or slot. So last, again, not least, VRAN and CRAN are features that have been popular for a while in open RAN, no dashing between specific sort of discussions. They were also supported part of the ORAN architectures, and now they're also supported in FAPI. So VRAN on the left effectively takes the layer 1 platform hardware and achieves isolation between carrier groups. Essentially, they're called PHY groups. So then application software instances represented here by VDUs can interact with these carrier groups independently of other containerized applications, and they can pool resources within and among the carriers in the cell group, but they're isolated from all the operations that other VDU instances in other containers would use for other cell groups or carrier groups. CRAN essentially allows takes advantage of the layer 1 hardware by allowing a pooling of frequency resources within 5 groups as well as across groups, depending on the capability of the hardware. So you can see here that prior to this baseband pooling feature, allocations in the carriers were accumulating in separate buckets. For instance, PDSCH or PDCCH, they're all subject to the individual carrier limits. With this baseband pooling capability, now the buckets are shared between carrier groups or maybe even across all the cells within an SoC. So this way, the hardware capabilities are fully utilized. So with this, I hand off to Simon.
Lovely. Thank you very much, Andre. It's a comprehensive summary for everyone there, which is, I hope, very useful to the viewers of this webinar. Right, so let's just talk briefly about where we're going with FAPI. It continues to be a focus for the collaborations between the members of the forum. There's I hope now you've got the general gist, but we will certainly talk about it a little bit more perhaps. 3GPP to ORAN alignment on features is important to us to make sure that we've got those covered, and that's a lot of the work that we do is to make sure that we're choosing where appropriate the different features. So you can see there listed your 3GPP and ORAN features that are coming through over the next beyond release 10 discussion area. Interesting to see red cap there perhaps for some people, NTN and some beamforming continues to be a feature set that we're quite keen on ensuring is supported. ORAN, Open RAN stakeholders is important for us as a forum, that we are looking at a diversified supply chain for those who are deploying and using small cells. So it's important that we keep focus on that for the FAPI activities. It's really member-driven feature set. So to get the driving seat in terms of steering feature sets, you need to be within the forum. However, we are more than happy to receive input from non-members, so we'll take those views into account, and you can see the contact details to get in touch with the forum if you have any explicit requirements that you'd like to be considered by FAPI. We've already mentioned the papers, the specifications that are relevant to the deliberations around the utilization of FAPI and front haul in general. I bring your attention in particular here to the SCF 270, because that, although that is a higher level system deployment level discussion document, it utilizes the DARTS tool to illustrate the bandwidth requirements. And as you've heard already on this session, the DARTS tool is compliant with FAPI. So we have quite a comprehensive coverage there. Okay, all right, thank you for that. I think we're on our final closing comments. I'd like just to do a couple of rounds of discussion, just really to emphasize the ORAN and SCF collaboration. Vikas, really interested in your summary view on how we manage that collaboration between the ORAN technical work and the SCF technical work. Your thoughts on how that works in the process?
Yeah, thanks, Simon. I represent both ORAN Alliance and the Small Cell Forum. We already have MOU signed between the Small Cell Forum and the ORAN organization. And in last Small Cell World Summit, there was a special session where from the London, and then ORAN Alliance was having face-to-face meeting in Korea. So we had a joint session together. So I think both of the organizations are clear on what they need to work upon. And we regularly meet both of the organizations to align ourselves. Past we have seen, but in near future also we are going to see a good collaboration between the two SDOs. So we not work in the isolation, but we work within collaboration with the other organization as well. And I think that's the key message, that we work with the collaboration.
Excellent, thank you. Yeah, and Andre, I mean, you've got dotted throughout the slide deck some conversation, or so you're presenting a view on the alignment with 3GPP and the ORAN Alliance. I'm interested if your slide, or you can just talk without the slide, just to re-emphasize again where we are on FAPI v10 and what we are supporting, and where we place the emphasis on those releases from ORAN and 3GPP and how it aligns with FAPI v10.
Thank you, Simon. So yeah, we try to be cognizant of 3GPP and ORAN, as well as any other relevant standards. But most importantly, we follow industry trends. The FAPI specifications are driven by membership, as you mentioned. So members of the Small Cell Forum are able to provide guidance and ensure that the FAPI specifications suit their needs. And as a consequence, we are now able to support ORAN up to the latest release. Happens to be version 18, nothing to do with release 18 in 3GPP, but it is the latest one. And as you saw, for instance, ULPI is supported. At the same time, in 3GPP, on the 3GPP side, we are up to release 17 in terms of capability. However, we're not covering all features. We're only covering those features that the members and the industry support. So for release 17, for instance, we cover RedCap and coverage extensions. The release 16 feature set is more comprehensive, although not complete. So for instance, no, the industry has not deemed it necessary to support sort of unlicensed access. So as a consequence, we're not focusing on that feature, but if industry ever finds it necessary, we will definitely adapt it. So as you can see, we are at the cutting edge, but we're not at the bleeding edge. We leave that to other organizations to handle.
Excellent, thank you. It's a good summary. I mean, actually that leads quite nicely onto, there was a number of slides presented today on the feature sets around MIMO and the capability that's been included into FAPI. I'm interested the new building blocks that have been put into the system. I mean, what's driving those additions, those features in the MIMO capability of FAPI?
Yeah, thank you for that question. So indeed, the MIMO has been a topic that has been of industry interest as well as academic interest since early days, even in 3G. Now in 4G and especially 5G has taken a more concrete realization. We being a kind of an industry-based group, we mostly focus on industry realities and practicalities. So we take, as I mentioned earlier, inputs from 3GPP, ORAN, as well as industry. So we adopt the MIMO features that 3GPP enables, such as SRS-based beamforming as a source for MIMO decisions, or CSI, RS as a source for MIMO decisions. From ORAN, we adopt features like QLPI as a way to improve onto MIMO performance. But that also leaves a gap in terms of coming with up, for instance, with downlink decoders. So that is seen from both groups as an implementation choice. However, from an investor perspective and from a private perspective, that still requires support between application software and layer 1 hardware. So that's where the small cell forum fills the gap and polls the membership for the latest and cutting edge MIMO features and adopts them. For instance, SVD-based downlink precoding and H-based precoding. ORAN is also expanding the feature set, so we expect this to continue in future releases.
Okay, excellent. Thank you. And Martin, just one last question for you. So you mentioned it. I'd like to just have a little bit of a thought process as you do chipset development as a company. I mean, interesting that the forum has and its members have decided that NTN, which some would remark perhaps is not very small cell in terms of the topology of the network as such, but it's interesting now to see the technologies that the SCF is using starting to go into other platforms. So your thoughts on the intersection between NTN and FAPI?
Yes, that's right, Simon. Thank you. Yes, you would think that NTN is quite different to small cell, but actually, when you look at the challenges in NTN, the things like size, weight, power, etc., chipsets that were designed for small cells are an excellent choice in building systems and architecting those. Now, of course, when it takes many years to develop a chipset, and when we set off to develop a chipset, we very much have volume markets in mind, not necessarily aware of the requirements of NTN applications. But now that we have that capability in terms of the components, it's the time is right to get the expertise in from the NTN community and start fleshing out the specifications so that moving forwards we can support that functionality.
Yeah, very interesting. Okay, so we've got another string to the bow from a systems perspective, which is great to see from the forum's perspective for sure. Thank you, Martin. And with that, I'd like to conclude this webinar and say thank you for watching. We will be running another webinar, no doubt, for version 11 of FAPI when it comes along. But before that, for sure, we will be having a market research webinar that we do each year, looking at the annual market research results that the forum generates each year and publishes. Currently, the members are looking at the output from that market research, but we will be sharing in due time the market research with everyone outside the forum as well, and that will certainly be a webinar to look forward to. And with that, thank you very much.